Hello and welcome to another video on the complete intro to SQL and Postgres as a way to keep up the pace and update my knowledge, especially on Postgres version 14. The current version at this recording is version 16, and this course is taught by Brian Holt. Okay, shout out to Brian Holt. This instructor from Frontend Master, which is a software engineer that has previously worked at Red, Reddit, Microsoft, Netflix, and now he is the PM of Snowflake, a data lake, or as you can say, is database as a service, cloud provider, and here we are. Okay, um, I don't want. I'm just going to make a quick recap here, what I have learned, which is okay. So jump straight forward to the introduction, or as a way to first know what we're gonna do today, which is write our own query specifically using uh, for the recipes here, which is the course that we're looking, or part of the exercise that we're doing. Okay, and make a quick recap before we actually jump to write queries and populate the data, uh, populate the database with the this migration that we have, this SQL. Okay, so here we look at the subtle difference between the SQL and the Postgres, as well as how you can set up your database using Postgres with Docker. So what is Docker? Which is this self-contained OS that allows you to run applications inside of your OS. And this is something that you have to pull an image and run a container. We also look at the difference between the image and the container. So the image is the ingredients, whereas the container is actually the dish already prepared. Okay, and then how we look at how can we create our first tables, how can we add columns to that, alter columns, how you can now do massive inserts, looking now at this most common operation that we do. Okay, first model the data by creating the tables and adding the columns, and then how you can now uh, get the data in to the database or into these tables using the insert. So how you can do single insert, massive insert, upsert, update, delete. And a key a side note here, this course is for developers. This course is not intended to teach how you deploy your Postgres or how you manage a Postgres instance or replicate that. This is not for DBA, okay, database administrators or DevOps. This is more for developers who want to know is how they can model data, how they can set up a database using Docker, how they can now think about filling data into the database or into the tables. Best ways to query your data from your applications. Identify and improve slow queries, and do all of this through node.js servers, especially using Express. So as I move on here, okay, and how you can now create your tables, how you can populate your tables, then how you can pull data from those tables using the select, okay, and how you can even paginate that, how you can do text search, which is very, very interesting, I must say, with like and I like. This is fuzzy search, which is a text pattern This is a text search pattern that it use, and the text and the patterns are using the percentage and underscore. Okay, what are they mean? What is the subtle difference? So percentage is for prefix or suffix of certain terms, whereas the underscore is more like, hey, find me this, find me words with this amount of characters. Okay, so I want you to now match is one character, or I want you to, yeah, I want you to do is one single match, whatever match it is, but I want you to do a single match in the text. Also, I look at how you can do paginations, the offsets. Why offset is not a good idea, especially if you don't have an index in your table, or for large applications. Okay, and then how we can use is SQL function, common SQL functions like count, concat. How now we can set up our first connection using Node and Express to the database by using is the PG, this particular library from Node. How we can connect to that? What are the type of connections? You have the client and the pool. How we most of the time when you have web server, you rely on pool connection rather than client, because single client or client connections are just single connections, which means that once you connect to the database and perform the query, you close that connection. So if you have now a server dealing with hundreds and thousands of requests, the left you don't want to do that over and over and over, which means that open a port, handshaking, set up the SSL, and establish the authorization, and all of that stuff. It is expensive. So the idea here is by having a pool of connections, you only ask to the client that have this pool, hey, client, query this. That's interesting. And that's the reason why we use pool. And then now how we can create our queries and how important is to prevent SQL injections. Why? Because you can lose your job and you can make the company crash by letting the user adding data to your, or by letting the user adding whatever data that you need or you can, and not sanitize your input, so you open yourself to trouble, because that users can be someone, can be some tech savvy that is not, that doesn't have good intentions, and then he can send a query. Okay, that the most common example of that is that it can send a query that select all the tables from a particular, all the column from a particular table, for example, student, and then he say, hey, now after that, drop the user tables. And when you do that, when you allow to do that, yeah, bye bye to yourself and to your business. So to prevent this, we use SQL parameterization. Okay, cool. And then we look at how can we now starting to write this particular query, simple queries, as well as pagination. Okay, simple pagination. That lead us is to the next topic, which is, okay, now how you, when you want to create more tables, now how you create is not only more table, but also how do you relate each others, and how you then combine data from different tables as a way to gain more insight about it. So first, relationship. We have several relationships, such as one or many, one or one, okay, one to many, and many to many. And how we can model that is also important. So in the case of how you can model many one to many relationship, okay, uh, yes. So in the case of you can model one to many relationship here, it's like, all right, the way to do that is using the reference keyword or this column constraint, table constraint as a way to set this uh, reference from the referencing table. Okay, so for example, if you have a recipe and you want to have photos for that recipe, you create two tables, all right, and in the recipe photos, you say, hey, I want you to create a reference to the ID of the recipe, okay, as a way to bind that. And there I want to have several photos, all right? Okay, this is a one way to model that data. And if you want to get that data, okay, you can do is something that we know as join, which is reaching two tables and then combine data into it. So in this case, you can use this join, which is just combine data. You can use inner join as a way to say, hey, this we want to do is one-on-one matching here. We can also use this left join, which is what if we want to include the not on what if we want to include is the one-on-one matching as well as whatever is on the left table. Right join say what if we want to include the one-on-one matching from these two tables as well as the right table. Okay, all right. And the thing we also have is what if you want to exclude data, okay, uh, what if you want the excluded data from the inner join in the left table, or what if you want to exclude what if you want to get the excluded data from the right table, all right. There's also an interesting this is here research. There is also an interesting image here that will help you fastly and how you can do that. Okay, what if you want the one-on-one matching? Uh, this join is actually if you use uh, so what this is if you want to say, hey, give me the join of this. So join me is all of this column that I'm telling you, and I want to select is the field from that. This is usually a join or full outer join. It's a join. Uh, and here we got is this inner join, which is 90% of the time you're gonna do inner join, which is one-on-one matching. If you want to include is the element of the left, you do is a left join followed by this query. Okay, it's a way to say, hey, if this actually, I want you to include whatever is on the left table, which is whatever is on the front. Okay, the table A, okay, with the table B, okay, and then I want now is the this uh, I want to check if their ID exist, okay, or if they have the if they have the same ID, okay, all right, give it to me. The same for the right join, as you can see, okay. What if we want to include is uh, those one-on-one matching as well as whatever is on the right table. This is what if I want to only what if I want to get the excluded data uh, from the left table, which means is don't include is the inner join. Give me the excluded data from the inner join uh, for that. And this is when you say, hey, well, as a way to get this this excluded from the left table, and now to look at where the key on the other side does not exist. Okay, when there is no when the key on the other table is null, all right, it means that you're gonna get is the excluded values here, or the right, or what I want to get is the excluded value from the right. The idea of this is to make yourself familiar with this terminology. What if I want the data from 101? What if I want the 101 matching? What if I want to include that from the left table or from the right table? Okay. What if it wants to get the excluded data from the left table or from the right table? You know what I mean? So this is just a way of how you can now combine your data as a way to tell the Postgres, hey, do the heavy lifting for me. A word of caution here. You don't want to your query do a lot of heavy lifting, uh, because that's not what you want. You want most of the time is to write, which is something that you can see that is fair common. You want most of the time is multiple faster uh, queries. That's what you want to do. So okay, after that, then I look at now how you can model is many-to-many relationship, which is where you have a table that have multiple reference. Okay, for example, a table that have reference from the recipe and the ingredients as a way to now, when you want to query the data, hey, what are the recipes ingredients here? Okay, and yeah, pretty much is this is a way of how you can now model this one-on-one or many-to-many relationship using reference, okay, as well as using something that is constrained, which is making compound is compound properties from different reference into a one single key, into a primary key. That's something that we did here, by the way. Um, Let me see, which is part of the constraint here. We already created. So, for example, here you can see here. This is a way how you can model this many-to-many relationship. Okay, as a way to say, hey, I want not the reference from the recipe, and I want the reference from the ingredients. Okay, and I want to combine them here, right? Uh, as a way to say, hey, this recipe contains this ingredient. Okay, this another recipe contains this ingredient. For example, in for example, xiaolongbao. Okay, xiaolongbao. This xiaolongbao, the ingredient is vinegar. Okay, so a recipe have um, a recipe of or this recipe ID, which is Shulongbao. Okay, Shulongbao. It can contain is vinegar as an ingredient. It can also contain is yeah, it can contain vinegar with pork, ginger. All right, all of these ingredients, right? So now you will have is one recipe reference with a lot of ingredients, right? So this is a particularly reference here. And the idea of looking at this, all right, is a way of how you can model your data and how you can theme in terms of model your data. Because there is no reason for leave there is no reason leaving down once you set your table. Okay, uh, because you can alter or adding a new constraint to that. However, which is now the next topic, constraint, is this. So thanks to the constraint, and this is one of the main reasons of using is Postgres or SQL, is that if you have a data, if you need highly structured data with a lot of constraint, SQL thrive for this. Okay, whereas for example MongoDB, Key or Redis, even though that they have some built-in constraints, uh, they're not designed. They were not designed for that. That's why we have SQL. Again, once you're starting to look at this particular constraint, sometimes or this most useful constraint like distinct is one of them, which is it gives you is the first incantation it finds. So it gives you is the individual distinct version of data. Okay. So for example, if you have a recipe, okay, and this recipe contains a lot of photos, okay, so it means that it has repeated, so it has a lot of repeated rows, okay, with different photos. It will say I'm gonna get is the first of this, I'm gonna get is the first row, and I'm gonna return that for you. So that's what this thing is doing. So another constraint is the check. And check is something pretty much like enum or a bag of constants, where you can say, hey, if you want, in order to populate this data, you need to satisfy this condition, or you need to provide me any of these conditions. So, for example, in the case of ingredients, okay, you can have types, and those types can be, for example, meat, vegetables, fruits, or others, right? So that's the idea of this constraint. And after all constraints, they serve to set rules to your column. Okay. So the thing with constraint, and especially when you need to recreate your schema, which is do a migration. If your database is big enough, I will probably not add that constraint. Okay, I will definitely probably not add that constraint. Uh, but if I have to do that, okay, then I will look, what I will have to look and update manually those rows that cause conflict, and then alter the table, and then run the migration. A word of caution here with alter tables and adding constraints. This is something that can and will cause the most downtime. This is something that you need to plan for it, because um, the TLDR is while you're doing this, while you're adding these constraints to the column, your server needs to still provide, your server needs to be handled incoming requests. So if your server is actually doing a lot of this heavy work, heavy lifting, well, you don't want to do that for that long. Again, your business is at stake. So the idea of running a migration here, especially to alter tables, to adding new constraint, is that you need to plan for this. You need to schedule for it, okay? Because you will have a downtime in your company. So usually this is something that you schedule early or late midnight, something like that. 1 a.m., 2 a.m., that kind of thing. And yeah. All right. So now, with that huge overview, which to me was very, very interesting as a way to describe all of these uh, topics that we have talked for, okay, uh, is this. Is now how we can go into actually is create our queries. Uh, Now using is join and constraint. Okay. How? By also looking at this distinct constraint. We also use some of this built-in SQL application or SQL command like coalesce, which coalesce is a nice little trick to let the database, hey, if you don't find any value here, I want you to fill that with some default value. Okay, that's what coalesce do. And then also a workflow anytime you're going to write your query, especially on Postgres, okay, or any other database, right? But the idea here is that uh, well, anytime you need to write a query, go to the database, get into the terminal, write the query, check if you actually get that data that you want to, all right? If it is, all right, now translate that the uh, to your route handler. Okay, so things started to make a lot of sense. Things started to make a lot of sense. Okay, cool, cool. So that's what we're gonna do here. Exactly. We're going to now, after we run that first query, let's make this left join. That's exactly what we did. Select this thing, which is, hey, give me is no, what the hell is this? No, what I have done? There you go. So this is the first query that we write here. It tells us, hey, give me is the first photo, and as you can see, you're starting to look at this particular pattern that arrives. Hey, give me is this. Give me is the first photo from this recipe. So anytime you have, for example, a one-to-many relationship, you wanna get is the first element in that relationship, okay, from the reference table, not the referencing, not the one that have the constraint reference, okay, not the one that holds the one that holds the reference, okay. Uh, this is a way of how you can do that. Hey, I want you to give me is the first element of this. Ah, this translate is to actually use a distinct. Distinct of what? Okay, distinct of a particular ID that you want to do that. Okay, so if you have multiple tables, which is not recommended, I definitely wouldn't want to do that. I prefer to work is with two tables to make our life much more simple. Okay, this is what you can do. All right, it makes a lot of sense. And here, because now we want is the data, uh, even we want is the data on the recipes. Get this left table or left join, and if there is no data on the other side, please fill that with some default value, coalesce, which is this. So okay, that was interesting. Most of the time when you do a join or when you do a left or a right join, okay, because in a join you will always get one-on-one matching. You're not gonna get empty data. When you do a left or a right join, you can, depending on the case, you can get some empty fields, okay? Because there is no overlapping, there's some fields on one of those tables that are not related to each other. So that's what we do is this coalesce. So that's very, very interesting. All right, next one. Uh, yeah, yesterday we went through this as a way to describe what's going on in this particular folder structure. Here is the index. As you can see, we define is this doc type with the input we're fetching is the swiper as well as the style from this. Uh, that's interesting. I don't have any style here. I know that you got it. It's here. This is the style that we're importing here. Okay. Um, this is the recipe guru. This is how you can navigate to that. Okay. You can navigate to complete ingredients or to complete recipes, or to ingredients or to recipe. All of this route must has been defined there on the model router. But what is the entry point? Client side static assets. That's right, which is serving is the index here, as well as the detail client serving is a static file, as well as the style, which is upper level here, and the detail HTML. Okay, so this is all. This is the two files that is serving, as well as the SSS, CSS, sorry, and the JavaScript here. So when on the index it asks for that data, you know where it's going to look, right? For example, here when the router exactly when someone actually require from a style, he know where to look at it. The same for detail and the same for detail client, as you can see here, there, right? In the case of this. So now client.js, it will gonna now load this particular script, right? So behind the scenes, what it's doing the browser is this critical rendering path, okay, as a way to create the DOM, the CSS object model, the render tree, okay, then the layout to finally paint the frame. Okay, okay. So, um, so yeah, this is what is going to run here as it is. This is what you're gonna do the first time, right? And when you navigate for the detail client, this is what you're gonna do. This is the data that is gonna load from there. You know, that's right. He's add the swiper here and that kind of thing, right? So when you're now are on the index, you will gonna load this script, okay? So when you navigate to the index, it will gonna ask the data to the server. Uh, here, we're gonna ask the data from the server. You're gonna get, hey, give me is the index.html, okay? And inside of the index.html, you will asking is for the styles, and then the server say, oh, I got the style, and this is the path where it is, you know. This is the style. This is the style, and this is the path where this file lives. Take it, send the file, right? And the response, and also So send the file, and as you can look at this, it say, hey, there is something called client.js. Okay, I need to also fetch this data because the initial time once the browser loads this is actually starting to parse the HTML and fetch the data that it needs to. For example, with link, uh, here is a body as well as the source. If you have an image here, image site recipe guru, okay. On the API, it will take a look at this. That you have that. It's not loading that, okay. Perhaps it's loading from some other places. On the image here, exactly, we have already this static image here. Food and site ingredient recipe guru is gonna load all of this from this image, and then he also going to now ask for the client.js. Okay, the idea of this is just to recap what it's doing behind the scenes. Okay, and how Brian Holt set all of this as a way to do this. Okay, so once it asks this file, it will run that, which is uh, now we're gonna load this data, parse it, and run this code. Okay, here, and when it runs this particular code, where it is right now, okay, and when it runs this particular code, he's going to fetch that data and then populate that as a way to now print or add it, as I mentioned here, as I mentioned here, add it, okay, add that data to that particular element. Hey, I want you to add this and this and this and so on and so forth. So, all right, and this is for the index, all the thing that's going on when index happen. And on the detail, this is all the thing that details we're gonna do when you click on it, when you navigate to it. You're gonna fetch the data here. It's gonna fetch this CSS from a remote server. It will fetch this data from this local server, this style. And we're gonna fetch the data from this local uh, server, uh, and he is now rendering all of this. Ba, 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 ba. And then now he finally going to load is these two resources here, JavaScript resource. I'm assuming that they put this thing as a way to identify what is going to replace, okay? Because what it's going to do here is is a text interpolation, which is great. Detail client, now this code, what it's going to do is to say, hey, I got all of these templates, okay? The template row, what you're going to insert here, the template ingredients, and the template list, okay? And when I need to request that data, which is using is the URL as an object, where behind, and also the URL search pattern. Okay, hey, I want you to now locate wherever is on the query patterns, here, window location search, okay? I want you to get me that data. That's something that I barely know about it. Location search. Exactly. The window location search. URL model browsers provide URL search patterns and URL search patterns to make it easy to parse out the parameter from query string. Document location search. Mm-hmm. But this is URL search pattern exactly. Query string of URL. So now if you say, for example, window location search, which is window location location, which is part of the instance property. Location is a read property, read only. The current location of the document. Mm-hmm. It gives you the current location of the document, and this location will give you now the search. Mm-hmm. Okay, when they call the location is that. Mm-hmm. Path name search and hash. Okay, the location for that. So this what it's doing behind the scene is to say, hey, window, this object that is relevant to the JavaScript browser, the web API. Hey, window, give me the location, which is the URL, okay, or the which is a read only. Give me the location here, okay, the URL, and thanks to the location has some properties, okay. I want now you to get me is the uh, search for that, which is the query string. Any string that contains a query string followed by the parameters of that. So that location, okay, would actually give you is this query patterns, okay, which will give you is the section, the segment that is after the query pattern, after the anatomy of the HTTP protocol, okay, or the local anatomy, or the location anatomy, which is the URL. So this, what it's doing is, hey, window location, where location is the URL, the location anatomy that it contains is the protocol, okay, the HTTPS, WebSocket, FTP, but the protocol, the origin, okay. Let me actually, in fact, show you what I'm looking right now. Is this the protocol, the origin, which contains this origin is the host name as well as the port, okay, and the path name followed by the search, which is this search query that we want to, and any hash for that as a way to get into the particular element on that document. So this is the anatomy of this, of the location anatomy. So once we get that, okay, and here we're gonna receive is this as an object URL search pattern, and thanks for browser now allowing us to make our life much more simple when we have to work with this, because now with this we can say something like a hash or like a dictionary, okay, or like a map. It's like, hey, get me is the ID from that. And now here, what I'm doing is preparing is the URL from this. Okay, as you can see, this is what we do always behind the scenes. In a lot of those frameworks, what it's doing is that behind the scenes. Hey, they are detecting whatever is on the location, window location search. They are detecting whatever is on the location, okay, and they adding that to URL search patterns. If that's what you want, that's a way to get me the query data here, okay, and then now construct the URL using this URL class. So this URL class here, uh, which now will be assigned to the URL cons, it will inherit all the properties from prototype through the proto change, okay? And here's when we're starting to say, hey, okay, this is when we're going to construct is our URL. Hey, this is the protocol, this is the host, as well as this is now the location here, okay? So how can we actually is from this location, from this window, uh, send the data to the proper URL, recipes, uh, get ID and that kind of thing. And that get me is the ID. So all of this was done uh, by the URL. And when you do that, okay, and when you do that here is this. It's like, okay, now with all of this thing that you done here, the URL, what you gonna do? So now that I have the URL, I want you now to request. Uh, I want you now to send a request to the server using the fetch, which is a built-in model in Web APIs. Okay, so this environment allows you to do this. Is now fetching it. However, because this URL is an object, you need it to send is a string. That's what they do. So what it's doing here is now creating this fork, okay? One of them where this respond, this REST object will hold a promise object in memory, in the local memory, and say, hey, I'm gonna have the value that right now I don't have the value, and they're gonna have is another property which is on promise or on reject and on fulfill, okay? We're going to pass now uh, some callbacks, which means what I want to do here. All right. And on the other side of the fork is letting the browser actually do the request, fetch the data, and if that is complete, so on complete, now you're going to update the state on that data. How so? By adding that to the micro task queue. This micro task queue is something that the browser is using behind the scenes as a way to, with the combination of the event loop, as a way to say, hey, which task do I need to run? Okay. First, the call stack is something important. The call stack needs to actually um, uh, the call stack must be empty before the event loop evaluate other tasks or micro tasks that it has on those queues, right? So micro task has a top priority than the callback queue or this task queue. So yeah, uh, and once that is done, okay, now I want you to the response, okay, transform or parse it into a JSON. So this operation is asynchronous, all right, which is great. So we have to wait for that. We repeat the process, and and yeah, okay. So that was very interesting as a way to recap what is doing behind the scenes. when you say populate. All right. So, all right. There is a lot of logic, a lot of steps here that is doing behind the scenes. And right now we're gonna focus is on the API here. We're gonna focus is on the API. We yesterday or yeah, yesterday we write or I wrote this query, and now it is time to go with this. Okay. So because here we're gonna write several queries, and here we're gonna get this data and the ID from the recipe ID. We're gonna do is couple things here. We're gonna do is couple queries, okay, couple faster queries, okay, multiple and faster queries. So first is the ingredients. So here we're gonna say is the hey, pool. I want to query this data, okay, which is uh, select 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 so because I don't know what is the shape of the data, okay, or I am not quite familiar with the shape of the data. Well, how can I do that? By getting into the Docker instance, and from there you say, hey, mm-hmm, yeah, by getting into the Docker instance and say, hey, I want you to look at the relationship, especially the ingredients table. Okay, this is the data that I need, that I want you to get from that. Okay, name the ingredient image. Okay, return all the ingredients row and as ingredient. Okay, so I want you to do is this. Get me is the name the ingredient image, which is this. I want you to give me is the um, select, okay, select for readability. That's the reason why I'm doing here. So select is ingredient ingredient image. Okay, select ingredient image. Mm-hmm. Or you say something like this. You say is image as ingredient image. Okay, because this is something that you're gonna select from this table, and because we are not doing multiple select, we can just do what it is, image as ingredient image. Okay, the image, let me put it this here, the image, the title as ingredient, yes, ingredient title here, and the other is the title image and type as ingredient type. Okay, that's good. From say uh, from ingredients, right? So I can say from ingredients, like that. All right, much better. So for example, for basic query, yeah, but if you want to write sophisticated queries, like so after you do this, okay, because this is a promise, you have to wait for this. All right, you have to wait for this, await. All right, now I'm going to get is the ingredients as a const. Okay, So if I now want to actually test this, okay, by saying something like this, the console.log of the ingredient, okay, and I want to then return something like that. So this query by using is now Thunder client, okay, I already have this open. I want is to now is do the get here, okay, test this. In our case it'll be with uh, get recipes, okay, we send that status not implemented, but I want it to now look at what it prints to. Okay, that's exact, totally. Get ingredients, vegetables, okay, all right. So get ingredients, all right. So we are successfully is testing and getting this query here. Okay, so far so good, no problem. Okay, so far so good, no problem. Already get that data. Let me actually do that request again here. Oh, it's undefined. Okay, that's exactly what I want to know. Oh, it's undefined. Perhaps you received that as rows. Okay, what about rows here? And if I send that request to that, say, there you got it. Okay, you receive now that as a rows. Okay, that's how you receive that data. Okay, that's how you receive that data. Interesting. You receive that data as rows. Hmm. Can you not rename that? Something like, say, as ingredients? Something like this. Something like this. When you query that data, it say no, row is not defined. Interesting. So you always have something called rows. All right. Okay. Okay. You're always gonna get is something called rows from that. So you can say is that wait for that. Okay. And then you're gonna say is well ingredients dot row. So by doing that, you're actually gonna get the data that you are looking for. So this might be one way to do this. Okay, so ingredients now is ingredient dot row. Okay, as a way to solve this particular issue. Okay, then we're gonna have is the another query return all photos rows as photos. Okay, which is now the same. Hey, bool. Yes, I want to query this data here, which is a select Okay, and because here this query is not that long, return the title body and URL. If you take a look now here at the recipe photos, return all photos, all photo rows as photos. Um, Recipe photos. Return all photos rows as photos. Title body and URL. Mm. So to return all photo rows as photos. Um, return the title body and URL. So I'm assuming it's something like this. There's a way to do this join. Mm-hmm. Return all photo rows as photos. From the recipe, title body, I think it's from the recipe here. You know exactly because it's a recipe that contains that. So in this case, if because of that, return all photos rows as photos. Okay, name the same, which is because we have now this join title body and URL, title body and the URL of that photo. So what we have to do is we're gonna do a join here, and we want to get return is all the photos that this recipe has. Okay, return all the photo that this recipe has, which means is that you can say something like this. The flying frog is this. Yeah, much better. And then you do this select, okay, because now we're gonna combine data from different tables, and we want to just get is the 101 reference. Well, we say, hey, recipe, okay, you're gonna select is the title, body, and the URL from you're gonna select the title, the body, and the URL. Say title from the recipe title from this table and the recipe table and the recipe photo URL from recipes. Okay, and we're gonna do an inner join because that's what we want. This one-on-one matching uh, of you're gonna inner join with the recipe photos, recipe recipes photos with RP as a way to provide an alias for that. Okay, on the key on the referencing table exists on the reference table. Okay, this 101. Okay, which is recipe the recipe ID. Exactly, recipe ID is equal to the recipe photos, which is the referencing table. Recipe ID is the same. So this will give us is the one-on-one matching here, even though it is copy. However, if you don't find anything here, coalesce, coalesce here. If you don't find anything here, okay, so if you have any value in the rel, good. If you're not, then set something to the default.dpg, okay. So once this query is done, okay, now it is time to say, hey, let me now assign this to the select title. This will be is what, the photos, right? Yeah, photos here, okay. And I want now to print that photos here. So we to say, hey, this is photos row. If I want to test this now and check out the here, it say this is undefined. That's interesting. That's very interesting. Oh, because I need to wait for this. This is an async operation. And there we got it, right? So we got this. Cookies and body, exactly. As you can see, exactly. It give us is those ID completely. It give us is those recipe that have several photos here, you know. This recipe have several photos here. So here in this referencing table, we have a lot of uh, reference to this one row. Okay, what is the next one? Hey, is this. Okay, how many reference do you have in the referencing table? All of this. Perhaps only one or two, you know? And then here. Oh shit. Uh, as URL. Okay, you have to be careful with that. Exactly. All right. Okay. That was beautiful, wonderful. Be right back. Welcome, 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 welcome. Okay, that was very, very, very interesting here. Completely. Because the idea here is that I'm returning is, well, if you're doing any inner join, you are in fact not need to do this because you're always guaranteed to return all the photos. Return all photo row as photos. Unless you do is some left join, for example, left join, and when you now make a query for that, you're gonna get is that. So, I think we're doing it right. Okay. Or in this case, get me only this data here. Okay. And now it is time to do the next one. Here. Return the title as title, return the body as body. If no row has no photo, return is as default. So as you can see here, we are now doing two queries. One for the ingredient, okay? One for the ingredients, okay, and the other is for photos. One for the ingredient and one for the photos. So get me is all of the ingredients for this table, and now get me is the photos from all of these recipes. And now you're going to return that in this particular format. And that is, instead of returning as a status for one, which is not implemented, I want you to return a JSON that will contain is this. Return as title and as the body. If no row has photo, returning as default. I think is, let me see how he how he defined that, because to me that's quite interesting, quite weird. Okay, okay. So here we're getting is all of the image, because here we get is the recipe. Exactly. We wanted to get this one recipe. Where you have is the ingredient. Where you're gonna have is all the image from that recipe. Okay. Where what you're gonna get is the image from that recipe. Exactly. Which is mm-hmm, which is where recipe recipe.id is equal to $1 as a way to do this query parameterization. And the second argument you're going to pass is the parameterized query, which is equal to the recipe ID that we're receiving here. Okay, so where recipe ID is equal to that value, which means is that give me is all of this. Okay, which gives me is 1. Okay, which gives me is just one of them, which is for example 1. He throw an error, get recipe. Oh, because I need to send that as query pattern. I think I need to send that as query pattern, query ID. Okay, yeah, as query pattern. Okay, no problem, no problem. Send that exactly. Get one. Well, because we haven't implemented that and we haven't print anything. So return all the ingredients wrote as ingredients. Uh-huh. But this is from the recipe. Okay. Return all ingredients wrote as ingredients. Exactly. This doesn't make sense. This data that you're fetching doesn't make sense because you are returning is all the ingredients. But this doesn't have any relationship here. You know? Or this, for example. So you can use return is the photo as photo.rows, and you can also is doing things like that. Okay, what you're going to return is exactly all the photos from this recipe. Makes sense? All the photos from this recipe. Totally. But now we need to also return is the recipe data. Okay, so okay. So here is when we're now going to say, hey, ingredient of what? What is the relationship? That's one of the reasons why you need to understand is the database, how this data is related to each other. Oh my God. Yeah, completely, man. That's when you need to dedicate your time and attention to how the data is modeled. Okay, okay. No, 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 no. Hell no, man. Hell no, man. Hell no, man. Oh my God. No, no, no. Exactly. A workflow. This is reflection, pain points, pain points. How model data, business specific, or how to model data, and how data is modeled. ChatGPT to ask to ask questions about that. Yeah, yeah, totally, man. Yeah, my friend. ChatGPT to ask questions about it. Holy hell. Yeah, okay. Alright. Jesus. Okay, okay. Mm-hmm. Mm-hmm. How data is modeled. ChatGPT to ask questions about that. Okay, or use a use a ChatGPT plugin to chat with databases. as a way to make sense of that. How model data and how data is modeled. Dim sum. Okay, because now we want is the ingredient here. Because now we want is the ingredient of these recipes. So this must be a relationship here. How is this relationship? One to many to many. If this is many to many, what do we want from this? Because I can say this, okay, this is title, image, and type, all right? But here, this is something that will come from the recipe, I mean, from the ingredient tables, okay, from ingredients. But the problem of this is that this one comes from the ingredients because we want us to know is the relationship data. So how many ingredients this recipe has, okay? And that is, well, we're gonna select is the ingredient title, image, and type, okay? We can make this as one query, which is the ingredient from the uh, yeah, that's right, from, so we're gonna get all of the ingredient of this. So from that relationship, okay. So from that relationship, recipes, ingredients, okay, or recipe ingredients. It has this relationship, as you can see here. So this is the table that we need to. That's what. Yeah, I need insights here. So ChatGPT can help me vastly here. RID, okay, from the as a way to know is what is this relationship here of this inner join. What is the one-on-one relationship? Okay, from the recipe. Okay, on exactly the inner join with recipes uh, on the exactly on recipe I recipe ID. Okay, is the same of the recipe ingredients dot recipe ID. Okay, this is as a way to from this relational table look those all of those matches here, inner join, okay, and the other is now do another join, which is inner join, okay, do an inner join, but now this time instead of the recipes, which is one of the reference here, is now with the ingredients, okay, which is the ingredients on doing the same. So whatever you find in this ingredient dot id, I think is ingredients dot id, exactly. It's a binary tree, exactly. Ingredient dot id da, 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 is equal to the recipe id, is equal to the exactly, is equal to the recipe uh, ingredients dot id. which is no, this is ingredient. I don't want ingredient. In fact, I want is the recipe ingredient, which is ingredient ID. Exactly. Ingredient underscore ID. Okay. So once you're able to do this, but I want to get this from one where where recipe where recipe the recipe ID is equal to whatever index that we're receiving here, okay, which is the recipe ID. This will give us, this query will give us is the ingredients. This recipe will give us is the ingredients that have one recipe. Okay, you're gonna receive this as an ingredient here. This is ingredients now. Ingredients dot rows. Okay, and then you're gonna get is that, right? Because as you can see, you're doing is a lot of join here, and this is something that can take quite a amount of time. So since this is from the recipe, since this is from the recipe, okay, since this is from the recipe, and here we want is the recipes, okay. Now we're also going to return is from the photos here. So ingredients, ingredient rows, the photos here. Or recipe, you can say this, recipe photos. You can say recipe, exactly. Where now recipe will contain is not only rows, okay, you can say recipe rows, which is doing something like this. And now, which is photos, okay, photos makes a lot of sense. Photos, okay, and the other is the recipe itself. So you got ingredients, photos, right? And now the recipe here. Cons recipe. Where here, this is more straightforward. You say, hey, let's go into a wait for this operation, for the pool operation query, okay, which is we're gonna select from the recipe here. So we're gonna select from the recipe here. Is the title body, exactly the title and the body. And yeah, title and the body. Title and the body. Which is returning is the title and the body from recipe where the recipe the recipe dot recipe ID, okay, from recipe where recipe ID is equal to whatever we are passing here as a query parameterization. But this must be passed as an array here, recipe ID here. So this recipe ID, okay, now we'll have something like this. So we have to return is the body. Okay, we have to return is the body, the title that will be is here, recipe dot rows, because we are returning is only one. We say, hey, this is the body, and pretty much the same here for the title. Holy moly, man. So when you do this, connection was successfully closed by a peer. Relation recipe does not exist because it's recipes. It actually crashed, as you can see, because we're not handling any errors. Okay, it tells us again error missing from class from table of recipe. Doesn't tell me which line. No, but it tells me, hey, there was a database error here from the recipe. Error missing from class entry for table recipe. Title body from recipe. Select title body from recipe. Okay, reload that again. Because we're recipes, exactly, where recipe is that. Okay, here we go. We crash that again. Error at near or near from. Mm-hmm. Mm-hmm. Okay, select here, recipe here, inner join recipe. and the ingredients here, recipe ingredients. Oh, is this? Yep, there you go. Okay, so this is ingredients. This is photos from the first one, and very yummy and cookies. Holy shit! Ingredients. Okay, ingredients, photos, exactly, and body and cookies. God. So after that, holy moly, you take a look at the location, and then you say, hey, you know what? I went now to actually look at the recipes. So we already successfully load all of his recipe. And when I want to take a look at the, for example, cookies, he rendered cookie properly, he rendered the ingredients and cucumbers, but not the photo. Okay, why not the photos? Okay, it rendered the ingredients properly, cherry, chicken, and cucumber, and the instruction, but not it's loading. It's not loading the photos. Okay, perhaps we're not sending the photos properly. Okay. Uh, mm, 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 mm. Return all photo rows as photos. Exactly. I am successfully returning is the photos here, but perhaps the way you are receiving those photos is not a proper format. Might be the way, might be the way. Yeah. So as you can see here, I actually did this ingredients, cherry chicken and cucumber, instructions, very yummy, as well as the image here. However, I'm getting is the image from cherries and sending is the image from cherries. Okay, so it actually properly loading the image from cherries, but not for photos. Maybe the depends on how was that set up, how is receiving the photos here. So if we take a look now at the code here, especially here on the detail, client on recipes here, the way it receiving this photo. Okay, 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 okay. Is it what is how the client is not receiving the photo? Exactly, exactly. Okay, okay. So because of that, and because we are sending you with the URL, mm-hmm, as URL. So the thing here is that you don't need that. You need is the row without the URL. Return all photo row as photo. Return the title, body, and URL. Name the same. Hmm. Mm. Yeah, but on the client side, when you await for those results, result.photos filter for those photos that are different from default. Exactly, because that's what it expects. Okay. Okay. Interesting. How do you do this as URL? Mm-hmm. Okay. Oh, our code works almost good, but it's a format that it expects. Mm-hmm. Mm-hmm. Okay. Let me now see how he made it, especially in the solution.
Oh no, that's not it. Right here. So now I have this pool that we're gonna put the search functionality or list functionality is aptly pointed out to me since we're not actually filtering it all. Okay, then I'm gonna say const rows equals pool await. Let me speed up the title. You need to join,
Yeah, the first one is like,
but we also need to include all recipes, not just ones that have images. So we're going to do a left join to include everything from the from table.
mm-hmm.
We're going to left join from r dot is to you could do pagination on this. Get rid of all of this. So recipes. No, crashed it. Where did I crash? This needs an extra. Let's try that. I forgot a.
No. Mm-mm-mm.
Oh no, that's not it. That's what it's supposed to be. So let's actually see what I did wrong.
Oh,
Choose
you missed a value here.
that is actually what's right.
Exactly.
So make sure you have both of the single quotes there. Now let's try that again. There you go.
There you go.
So see, these have photos, the ones that do, and you can see some of these have this like photo like that looks like this one. That is the default photo. Whatever. That's when your app just is giving up and says whatever. I don't care. Let's hop into the get.
Okay. Let's hop into the get. Let's hop
So
into
again,
the
I
get.
broke this into two photos. I broke this into two queries, and that just made sense to me. But just like programming, there's like a ton of ways to do the one thing. Same thing in SQL. There's a lot of different ways that you could have done this. You could have definitely done this in three queries, right? One to the recipe table, one to the recipe photos table, and one to the ingredients table. And I would have definitely accepted that as correct as well. Const ingredients, the
Yeah.
recipe table, one to the recipe photos table, and one to the ingredients. Same thing in SQL. There's a lot of different ways that you could have done this. You could have definitely done this in three queries, right? One to the recipe table, one to the recipe photos table, one to the ingredients table. And I would have definitely accepted that as correct as well. Const ingredients promise equals pull that query. This is just how I like to code JavaScript. You don't have to do it the same way. You could definitely do an await here. But here I'm actually just going to grab the promise. And then I'm going to say select i.title as ingredient title. All right. Little clause, right? But you can basically think of
Exactly, because the idea of there is to say, hey, I want now to get is this data. I want to get is the ingredients that are on the recipe.
comma in my speech. Ingredients I on i.id equals ri
The
ingredient
other ingredients.
id.
Mm-hmm.
We're grabbing all of the various ingredients that exist for any one recipe based on what the recipe ID is. So here we're just going to give it the
Exactly. So here we're grabbing is this is something very very important here to describe, man. This is something important to describe here with this because we're grabbing is several ingredients that have this recipe. And I'm going to write it down. And I'm going to write it down. So again, so this is now the multiple queries that we write here. This is actually pretty straightforward for the search list. And the other is for the get. Holy shit. All the inner machinery that need to have all the hard work and all the heavy lifting that it needs to happen as a way to actually do that. So now this is get. Get and so get recipe. So this first query, so the first query here, I'm grabbing, I'm grabbing, I'm grabbing. How do you say? Grabbing? Exactly. So I'm grabbing all of the ingredients from one recipe. That's what we're doing here. I'm grabbing all the ingredients from one recipe here.
ID. Okay, this is the first query that I chose to write.
Mm-hmm.
The second query that I'm going to choose to write
These are the photos.
is the photos one. Const photos promise equals pool.query select
Where in the select,
title
we're gonna get the title.
body. This is what I'm saying. This part could have been a third query where you just get the recipe details. I chose to put it together with the photos because that made sense to me. It's one type query. It wasn't that hard to do. Here I'm going to say coalesce.
Mm-hmm. Which is join coalesce. Is you don't have any particular value on URL. So doing this
as URL from recipes are, put on the line or not, either way.
where here what you want is to get all of the photos from that, which is a left join.
Here we're going to say left join, right?
Mm-hmm.
You want to grab all recipes.
We're gonna grab all of. We're gonna grab all of the.
This is like a single detail page. If there is no photos, we still want the recipe.
Because it's a detail page, there is no photo. We want to still have the recipe. And yeah, photos promises, and a left join because we're gonna get all of the recipes. Totally, we're gonna get all of the recipes. Photos.
That's what the left.
We're gonna get all of the recipe here.
Means in this particular context. Recipes, photos, RP.
Mm-hmm.
RP.
So we're gonna get all of the recipes, okay, and include those recipes that has photos
equals R
or not.
Recipe ID.
Where
lastly, we need our where
the recipe ID is equals to $1, which is the query parameterized. So far so good. It's like exactly. So far so good. It's like no problem with that. Actually, in fact, do the same, which is here. But here I just only get is the URL and the other query. No, in fact, I do two of them. In fact, I do two of them. Wait, I did two of them? Bullshit. No, I deleted, in fact, one of them. Which is here, recipe.
Okay, so now I have these two promises.
Oh, I get why he's doing that with promises.
Here's my thinking here. You can say await here and await here. The way that await works is it's going to pause execution until this happens. Then it's going to go here, and it's going to pause execution until this happens. I actually want both of those queries to go out at the same time, right? Because it doesn't matter what order they come back to me in. And I want to pause and wait for both of them, right? Does that make sense? So you can do this with something called promise.all. This is just a JavaScript thing and how I would write this code. So I can say this is going to be photos response, and then ingredients response equals promise.
Because exactly, that's going to pause the execution.
And you just give it an array of promises. So this would be photos promise, and then ingredients promise.
That makes a lot of sense when it comes to actually handle this data.
And then all I have to do here is just say await. So here's what's going to happen kind of in real time. It's going to call this, but it's not going to wait. It's going to immediately call this one as well. So two queries are going out like not simultaneously, but in quick order of execution, right? It's not going to wait to call photos promise for this one to complete. Here, when I say await promise at all, it's going to wait for both of these to finish. Once both of these have finished, then the execution will resume. Okay, and then now I have photos response.
Once both of these are resumed, now the execution is resumed.
Photos row equals photos response dot rows and const ingredients rows equals ingredients response then down here, res.json ingredients. I'm just going to give it ingredient rows.
Exactly, ingredient rows. But here we're talking is about is now handling it, because what's happening is that I'm pausing that execution, and then I'm pausing the next execution, which is something that you don't want.
Photo rows. If you look at the code here in the detail.js, it's expecting them to just be direct images, just URLs. It's going to give them back to you as objects. So I need to transform them. There's a couple ways you could totally do this. You could say for, and I'll just read this. This might be the easiest way. Let I equal 0, I is less than photos.
When you find yourself doing that kind of thing, it's like
I plus plus.
when you find yourself doing that kind of logic in your and we'll just say
photos.
that's an indication that you need to go back to rethink your schema.
Right. So then this photos array will just be URLs, right?
Because imagine that you have to deal now hundreds and thousands
here I can just say
of
photos. Right, these photos that I created up here, or I can just say photos like that. Title in photos, rows. We can just grab the first one, right? And grab the title off of that because it's going to be the same for all of them. And same with body. It's going to be photos, rows, 0.body. But if you did a separate query for that, you would grab it out of the separate query. So if you're reading through my completed code, it's a little bit more clever in terms of how it does it, just because that's how I write code. I tried to be a little bit more explicit here as we wrote it together, but just to walk you through it really quick in terms of how it does it, just because
exactly.
That's how I write code. I tried to be a little bit more explicit here as we wrote it together, but just to walk you through it really quick. Oh, I have it here as well. API for completed recipes.
Completed recipes.
Here I do all the destructuring in one line. But notice it's grabbing photos rows and ingredients rows the same way. It's just doing a little bit more terse syntax. And then here, instead of doing like a for loop to grab all the URLs out, it does a map, which does exactly the same thing. Otherwise, exactly the same. So let's get rid of that. So now let's go look at our project. This still works okay. Let's look at cookies. We get butter, eggs, brown sugar, milk, sugar. And notice we're getting all of our photos down here, and all the ingredients get put in here as well. So hopefully it's fairly demonstrative of like, this is really what it's like writing SQL code together with backend code.
Yeah.
This is generally what it feels
like. My God. Okay. All right. All right. Okay. There were something. Okay. There's also pain points here. Pain points here, which is especially from JavaScript. Okay, especially from JavaScript. Pain points here is that promise in async code. How it works. Okay, pain points, promise, and async code. This is my flaw here. All right. So with that, that was quite interesting. That was quite interesting, by the way. Totally it is. Oh my God. So I know how to write queries but I didn't know how to get that data from that, which is something that I know how to do that. So yeah, oh my god. With that, that'll be all for this video. Take care. Bye bye.